Hello guys, I am Varun Kulkarni and in today's video I will be speaking about qubit. I will start by explaining what exactly a qubit is. A qubit is basic building block of quantum computing in which quantum information is stored. It was in the year 1995 that Benjamin Schumacher, an American theoretical physicist, coined the term qubit. I will now explain the representation of qubit. A qubit is a linear representation of the two basis states or vectors. These basis states or vectors are called as ket0 and ket1. When these basis states or vectors are clubbed together, this is actually linear representation of 2D vector space of qubit. A qubit exists in two types of states. One state is pure state and the other state is a mixed state. A pure state is obtained when these two basis states are in coherence with each other. For two waveforms to be in coherence with each other, for two waves to be in coherence with each other, their waveforms and amplitude should be identical. So a pure qubit is represented by the following equation. Phi is actually representation of qubit. Alpha and beta are amplitude probabilities. While measuring the qubit, when we apply the Born rule, the probability of finding ket0 basis state with value 0 is mod of alpha squared. That is the value of the complex number alpha and its squared. Similarly, when we apply the Born rule for ket1 basis state, the probability of finding ket1 basis state with value 1 is mod of beta squared. And as we know, no probability can be greater than 1. So this equation arises: mod of alpha square plus mod of beta square is equal to 1. So this is the representation of pure state of qubit. Now, speaking of the mixed state of qubit, the mixed state of qubit takes place when there is decoherence and quantum noise. So due to decoherence and quantum noise, when there is a mixed state which takes place, so there is also probability of loss of quantum information. So to prevent this loss of quantum information and to save this quantum information, quantum error correction is a technique which is applied. Now, speaking of physical implementation of qubit, there are many methods by which qubits are physically implemented. One method is superconducting wires. So superconducting wires, they consist of persisting current, and the two different directions of the current represent the two different states of qubit. Apart from superconducting wires, there are various ways in which qubits can be physically implemented. For example, trapped ions, quantum dots. Qubits are fundamentally different from classical bit. A classical bit can exist either in value 1 or in value 0 at a time, but a qubit can exist as a superposition of the value 1 and 0 at the same time. So due to being existing in superposition of values 1 and 0 at the same time, qubit can carry much more information than a classical bit. Another advantage of the property of qubit is quantum entanglement, where the states of two qubits are not independent of each other, and this property of quantum entanglement is used in quantum cryptography, and the classical bit does not have this property of quantum entanglement. So this is what I have spoken about qubit. I hope you liked this video. If you have liked this video, do give a thumbs up, comment, share the video, and do subscribe to my YouTube channel. I will be coming up with more informative content on electronics, embedded systems, theoretical computer science, and mathematics. So stay tuned. Thank you.